Hi everyone, and welcome to our video on using a calculator to solve trigonometric equations. So in these three trig equations, so we have a sine, cosine, and tangent, we have them set equal to values that are not on our quoted unit circle. And what I mean by that, let me scroll real quick, like this problem, where we would say, well, that is 1/2 as a y-coordinate, and we would find those angles and continue onward from there. Okay, so that's using the unit circle that we know so well. Well, they don't have to give us those values every time. They can be values that are still on the unit circle, just not on the main one that we use for exact values. All right, well, all we have to do is just mess with our final answer because our calculator will give us a single answer because we need to use inverse trig. So remember, inverse trig will always give us angles. So let's solve these. So for number one, solving sine of x equals 1/3. Again, we know that that's not on the unit circle, the quoted. However, we can still draw the circle and say, well, that's still a y-coordinate, and that would be maybe somewhere there-ish and somewhere here-ish. Okay, so I have a y-coordinate, so I don't care about the x-coordinate. We could find it if we really wanted to. But just to say, well, that 1/3 is a y-coordinate. I know 1/3 appears twice in the first and second quadrant because that's where the sine function is positive. All right, well, again, I can't use the quoted unit circle. Those aren't on there. But I can take the inverse trig function of both sides. So if I do the inverse trig of both sides, I'm going to give myself plenty of space and just rewrite those to the left. Okay, so that gives us sine inverse of sine of x equals sine inverse of 1/3. And then on the left, we're assuming the x is defined, and it will be, but these would then cancel out, and we'd be left with x is sine inverse of 1/3. Okay, however, we introduced the trig, or we introduced inverse trig, and again, that only gives us one answer. So in this case, this sine inverse of 1/3 is going to match with that first answer right there. All right, well, let's calculate that. So we've got trig function sine inverse of 1/3. Now that is our degree answer. They probably do want it in radians. I don't think it's said, but they will often tell you which one to do. If they don't, we would assume radians. Okay, so let's click radians. And then let's do this to 4 decimals, or how far did it say? 2 decimals. Okay, so we'll round this to 0.34. Okay, so 0.34 right there is that answer that's marked in the maroon. So let's keep it in maroon. Okay, and then instantly, just like the other problems, if we're solving for a trig function, we know we will just add 2 pi k to this answer eventually, so might as well do it now. So plus 2 pi k. And then comma. Now again, we want this other one. Let's color code it in green. We want this other answer. That wasn't found on the calculator because the calculator can only give us one. But all we have to do, so for our sine answers, is take our previous answer that we just found, the 0.34, and do pi minus it. Okay, the reason for that is, let me mark it in pink. So this length is pi. We know that, let me mark it in one other color. Let's do, kind of running low. Let's do orange. There we go. This length and this length are the same on the unit circle. And so if we take the pink length, which is pi, and minus it by the orange length, that would be, let me mark it in green all the way, that length right there. And that's the second angle that we're trying to find. Okay, so so I hope that it's a little tough to see with the picture, but, or you could just think, oh, I should just take the answer and do pi minus theta and be done with it. All right, so for this answer, we're going to do pi minus the 0.34. That's going to be right here. And then we'll still add 2 pi k to it. All right, so I just need to go to the calculator one more time. So we've got pi, and then minus 0.34. And there we go. That's our second answer. So 2.80 in radians. So we have 2.80 and then still plus 2 pi k. There we go. There's all solutions to our sine equation there. Okay, let's go ahead and do these other two. So cosine of x, if it's equal to 0.65, still I can at least show that. That's an x coordinate. An x coordinate that's 0.65 is maybe about here and also about here. So cosine's positive in quadrant 1 and quadrant 4. Again, the trig function, when we do an inverse trig function, will only give us one answer. All right, so that means, like on the previous problem, I'm just going to say I should do a cosine inverse of both sides. It's a little sloppy. But what that does for us is it gives us one of our answers. So x would be cosine inverse of 0.65. Again, to color code it, let me mark it in the maroon. That would represent the first angle there based on the way that inverse trig functions work. All right, so we would plug it in to our calculator. Let's get it. Okay, so I've got cosine inverse of 0.65. And to 2 decimals, we would have 0.86. So we have x is equal to 0.86 radians. And then like before, we'll just say, well, they would want all solutions, so might as well do plus 2 pi k, comma. Now the one in the green, this answer, that would have been found. Again, we can mark it up like the trig function. These two are the same length. So you could also, for cosine, just take the negative of the previous answer to get it. Okay, so negative 0.86 would also work. However, they might not want a negative answer, and it really doesn't matter. But if they're being like extra picky, they might not want a negative. So that's where we would say, well, if I had gone all the way around instead, and then minus that little length in orange, that should still match where the green puts me. Okay, so that's why we do 2 pi minus that angle. Okay, so now we're going to do 2 pi minus 0.86. And that's our second angle, so 5.42. Okay, so in green, oops, that's pink. Okay, so that was the 2 pi minus the 0.86, 5.42. And then like the previous answer, we would say, well, they want all solutions, so we should just do plus 2 pi k. Okay, so there's our two answers that time. Now our last one with tangent. So this is tangent of x equaling negative 7/2. I mean, just like those others, we could draw our unit circle. Where tangent is a negative value would be in quadrant 2 somewhere. So I'm just going to put a dot here, and quadrant 4 somewhere, like that. Okay, and then we can do our tangent inverse of both sides. So if I did tangent inverse of both sides, well, it's a little messy there. Let me just write it a little to the sides. So I'm just setting up in the blue the tangent inverse of both sides, and that would be tangent inverse of tangent x would equal tangent inverse of negative 7/2. And then the left side, the x would cancel, and we'd be left with the tangent inverse of negative 7/2, which would be this point in the maroon. Okay, so x is tangent inverse of negative 7/2, and then let's get it in the calculator. Okay, so I know it's there because tangent inverse, so we have all these properties with inverse trig. Tangent inverse is always between negative pi halves and positive pi halves. So if it's a negative value in tangent, that means it should be in quadrant 4 as a negative angle. But we'll see that anyway if we're using a calculator. So we have tangent inverse of negative 7/2. And that gives us that angle right there, negative 1.29. Okay, so we have negative 1.29. And then like always, we would say, well, we could just add 2 pi k to it. Tangent, you could actually just add pi k, and we would be done with this problem. But I think for the habit of sine and cosine and other scenarios, it might be nice to get that other one. Okay, so in the green, tangent has the property of having one period being pi. So that means these are pi apart. So that means whatever this answer was in the maroon, I can just add pi to it to get the second answer. Okay, so that would be, let me do it as an arrow again, negative 1.29 plus pi would give me that second answer. And so when we type it in, plus pi, gives us 1.85. And then still plus 2 pi k for all solutions. Okay, there we go. Okay, so that's how we can deal with it with a calculator when we need all solutions. Now, inverse trig is special. It only gives us one, but on these problems, we often need more than one. So I would still draw the unit circle like I was doing. And if you get stuck about knowing what to do with the pi or 2 pi, it can help with marking it like this. And these pictures are a little small, so if you're really stuck, draw it nice and big, and we can try to figure out those links based on the properties of the full unit circle. All right, well, that's it. If you do have questions, please let me know. Otherwise, thanks for watching.